Okay, let's go over this activity 2.0 that you just completed in your groups. So the first part here is just going over what we've learned about geometric sequences and how to use the recursive and explicit formulas to find different terms in the sequence. So to use the recursive formula to find the ninth term, we're trying to find f of n, which would be the next term. I know that right now I have 5, and I'm going to multiply that by 2. Oops, not by 5, by 2. So my next term is 10. Of course, to find the ninth term, I'm going to have to do that, 7 more times to find the ninth term. So I would continue this pattern. It's much easier to use the explicit formula. So to write an explicit formula for this sequence, I know I'm going to have f of n is equal to, my start is 5 times, the common ratio is 2. I started at 1, so 2 to the n minus 1 power. So if I want to determine the ninth term in the sequence, that means that n would be 9. So I'm finding f of 9. So that's going to be equal to 5 times 2 to the 9 minus 1 power, which is 5 times 2 to the 8th power. I'm going to use my calculator. 5 times 2 to the 8th power gives me 1,280 for the ninth term. So which form is more efficient? It would be the explicit, because you don't need to know the previous term. Don't need 8th term. So we talked about how in geometric sequences, repeated multiplication is written shorter as an exponent. So in this lesson, you're learning about different exponent rules. So shortcuts that you can use when working with multiple exponents in an expression. So 2 to the 4th power times 2 to the 2nd power. In expanded form would be 2 times 2 times 2 times 2 times 2 times 2, which then if I simplify this, I get 2 to the 6th. 3 to the 5th power is 3, 5 times 3 squared would give me 1, 2, 3, 4, 5, 6, 7, 3 to the 7th. Here I have 3 negative 4s, so that would be negative 4 to the 3rd, and make sure you put the negative 4 in parentheses because we're multiplying negative 4 times negative 4 times negative 4 times, there's 3 more here, negative 4 to the 3rd. I have 1, 2, 3, 4, 5, 6 negative 4s to the 6th power. So 12 5s, 2, 3, 4, 5, 6, 7, 8, I'm going to make that one group, times 9, 10, 11, 12, right? So for me, you could have done any combination here. I have 5 to the 8th times 5 to the 4th. So the question is, how can we get from this column here to this column here without having to do expanded form? Because that could be really difficult if we're doing, you know, x to the 100th times x to the 1000th. I don't want to write 1,000 x's. So you should have figured out that the shortcut would be that we can add these exponents. 8 plus 4 is 12. 3 plus 3 is 6. 5 plus 2 is 7, right? So I could do x to the 20th times x to the 7th very quickly is x to the 27th power. Now notice that all of these, the bases are the same. Only 2's, only 3's, only negative 4's, only 5's, only x's. Because if you try and simplify x to the 5th times y to the 3rd, if I write that in expanded form, times 1, 2, 3, I can't combine these at all. It's like apples and oranges. I just have a group of x's still and a group of y's. So the rule with this, write this maybe really big on your paper, is that you need the same base to use this rule. Let's look at the other side. So your rule for multiplying exponents with the same base would be if you're multiplying any number a to the x power times any number a to the y power, you're going to add the exponents, x plus y. Again, you must have the same base. So now let's look at division. I have 2 to the 5th divided by 2 to the 3rd power. So 2 to the 5th in expanded form here. 2 to the 3rd is expanded form here. So if you think about it, 2 divided by 2 is just 1. 2 divided by 2 here is 1. 2 divided by 2 here is 1. So really what I get is 1 times 1 times 1 times 2 times 2. So how many 2's do I have? That would just be 2 squared, because anything times 1 is just itself. So here the quotient would be 1, 2, 3, 4, 5, 6, 7 to the 6th power divided by 7 to the 3rd power. Again, I can cancel these out because when I divide them, I just get 1. So I'm left with 7 to the 3rd power. I'm going to do 8 times 8 times 8 times 8 times 8 times 8. 1, 2, 3, 4, 5, 6. I'm going to do 8 to the 6th divided by 8. 2 8's cancel because when you divide them, you get 1. I'm left with 8 to the 5th. Again, for this one, these two, you could have had any combination as long as you were left with 8 to the 5th. So the question is, how can I get from this column to this column without having to write in expanded form? And hopefully with your groups, you discovered that you can subtract the exponents. 5 minus 3 is 2. 6 minus 3 is 3. 6 minus 1, remember if there's no exponent, it's 1, is 5. So here, I would get x to the 20 minus 7. You do always have to subtract numerator minus denominator is equal to x to the 13th. So when you're dividing exponents, again, with the same base, remember they have to have the same base, any number a to the x power divided by any number a to the y power is equal to a to the x minus y power. You subtract the exponents. You must subtract the numerator exponent from the denominator exponent. Hopefully when you type these into your calculator, you got 1, 1, negative 1, and 1. So you should have noticed that anything raised to the 0 power is equal to 1. Our rule that we made in 5C for why we think that let's look at 2 to the 2nd power divided by 2 to the 2nd power. Remember, our rule is that we subtract the exponents. 2 minus 2 would give me 2 to the 0 power, which we know is equal to 1. If you expand that, 2 times 2 divided by 2 times 2, remember, 2 divided by 2, 1. 2 divided by 2, 1. So 1 times 1 is just 1. That's where that rule comes from. All right, so now we want to use our rule from 5C to simplify this. Remember that you always have to do numerator minus denominator. So x to the 5th power minus 7, which gives me x 5 to the negative 2. If I write that in expanded form, I have x times x times x times x times x divided by 1, 2, 3, 4, 5, 6, 7. If I do my division and my canceling to get 1s, where this time am I left with the 2 x's? They're in the denominator. So up here I have 1 because when I divided all these I got 1s. 1 divided by x squared would be your solution. So in part A, I have x to the negative 2. In part B, I have 1 over x squared. So to simplify a negative exponent, you move it to the denominator and make it positive. Stanley created this general rule, 1 over c to the n power. 1 it would be c to the 0 power. Okay, I agree with that. So then we would subtract 0 minus n. So c is equal to negative n. So here's your rule, negative exponents. Perfect. I do want to add, I don't think that's on the back, if your negative exponent is already in the denominator, like say you have 1 over x to the negative second power, in that case, you would move the x to the numerator to make it positive. So that's equal to just x squared. And that goes back to your rule with dividing fractions. What this really is 1 divided by 1 over x squared, right? And when you divide fractions, keep the numerator, change division to multiplication, and multiply by the reciprocal, x squared over 1, which gives us x squared. So negative exponents move to the denominator to become positive. If the negative exponent is already in the denominator, it moves to the numerator and becomes positive. Last page, fill in the table below to learn about powers of products and powers of quotients. So if your exponent is on the outside of the parentheses here, what this really means is 2x times 2x times 2x times 2x. So we can combine what looks the same. All of these coefficients, these numbers, we can multiply together. 2 times 2 times 2 times 2 is 16. And then I have 1, 2, 3, 4 x's. Here, I have 2 x's, 2 x's, 2 x's. That's a total of 6 x's. I have 5, 10, 15 y's. So this exponent here, since I have 1, 2, 3, that exponent would be a 3. X to the 5th divided by y to the 3rd times x to the 5th divided by y to the 3rd 4 times. So now 5, 10, 15, 20 x's, so x to the 20th. In the denominator, I have 3, 6, 9, 12 y's. This is negative. So that means I'm going to do 1 over 3 over y to the 5th times 1 over 3 over y to the 5th times 1 over 3 over y to the 5th, right? Well, dividing fractions, keep the first term, multiply by the reciprocal. I'm going to keep the 1, multiply by y to the 5th over 3. I'm going to keep the 1 and multiply by y to the 5th over 3. I'm going to keep the 1 and multiply by y to the 5th over 3. And remember, all these 1's are like 1 over 1. So when you're multiplying fractions, multiply all the numerators. 1 times y to the 5th is y to the 5th, times 1 is y to the 5th, times y to the 5th would be y to the 10th, because I have 10 y's. Then I have 5 more y's, so that would be y to the 15th. Over, and then the denominator 1 times 3 times 1 times 3 times 1 times 3. 3 times 3 is 9, times 3 is 27. So the question is, how do we get from this column to this column without having to write an expanded form? What you should have seen is that you are distributing this exponent to everything in the parentheses. Right? So x squared times y to the 3rd, all raised to the 3rd power. I'm going to distribute the 3 to both exponents. 3 times 2 is 6, so I have x to the 6th. 3 times 3 is 9, I have y to the 9th. So my rule here would be any number a to the 3rd power divided by b to the 4th power raised to the 3rd power would be to distribute that exponent to everything in the parentheses. So a to the 6th divided by b to the 12th. Remember up here, this coefficient has an exponent of 1. So that's 4 times 1 is 4, and 2 to the 4th power is 16. If you need a little bit more help with exponent rules, I'm going to put a Khan Academy video on the website as well. So you can watch that video when you work on your 2.0, the set, if you need some extra help.